Thank you, everyone, for joining this session. We hope that if you went to the plenary, you enjoyed it. And I'm going to pass the reins right over to Doug Newman.
Hey everyone. So the title of this session is the state of ESDIS. I'm going to give a brief introduction. Then I'm going to hand the reins over to Tim Goff, who's going to give his talk on recent changes that we've made and the areas of AWS infrastructure, etc., and what that might mean to you as clients of ESDIS or users of ESDIS, and then to Shannon Leslie and Tyler Stevens to get a report out on subject dear to my heart, metadata improvements and how we're going about them over the last year. But I will start with this intro and giving you a brief overview of what's happened in ESDIS over the past year. First, the ESDIS civil servant staffing level through various things has been reduced by about 50%. And the presidential budget called for a significant reduction in science funding, which translated to initially around a 63% cut for ESDIS. However, the good news is ESDIS still exists. And as you're probably aware from the news, Congress has passed an appropriations bill which changes that across the board to just a 1% cut to NASA science. However, this still needs to be signed by the president, and NASA SMD need to allocate that budget as they see fit. So it's looking a lot better than it used to, but as one of my colleagues said a few days ago, I'm not popping any champagne corks yet, but it's looking good. And the other really big piece of good news is that we launched NISAR. What that means to ESDIS is that we will double the size of our archive in 3 years of that mission, just through NISAR alone, irrespective of any other holdings we gain. NISAR alone is double the size of our current archive. What we've done this year, other than that, I'm going to go through some of my personal highlights, and caveat is I'm kind of biased towards the discovery side of ESDIS because that's where I grew up. ESDIS is common metadata repository, our catalog system for our archive. Had a performance requirement of what we call sub-second search, which means 95% of the queries that come into CMR are resolved in less than a second from the point where they enter our service and where they exit. In the last couple of years, we have not been meeting those performance requirements, so I challenged the team to meet that performance requirement by the end of 2025. And they managed to do that. So kudos to them. So we're back on our nominal performance for CMR, even though we have an inventory of 2.4 plus billion granules. We've launched the prompt-based API and user interface for search and discovery. That's its cmr.earthdata.nasa.gov/NLP, which allows you to query CMR collections using a chat GPT-like interface. We hope to integrate that with our Earth Data Search client very soon, early this year. We have significantly increased the quality of our metadata records in the area of collections and continue to do so. More on that later from Tyler and Shannon. And we've introduced third-party identity providers for EDL. So you can use your social login of choice when creating or managing your EDL credentials. And finally, Tim is going to touch on this in his talk, we've made large cost efficiencies with storage, which is our biggest cost driver. We have a substantial amount of data, as you may be aware, and using different strategies on how we store that data through managed services in AWS, we've managed to reduce our costs in the area of storage significantly, which is good because our budgets aren't getting any bigger, and the amount of data, as I mentioned with NISAR, is getting extremely larger. So we'll continue to work on this. We are committed to our core mission, the stewardship of all of NASA's Earth science data. That means the ingest and archive of that data from orbital, suborbital, and in-situ data providers, 2.4 billion plus granules, 128 petabytes of data, soon to be doubled with NISAR. We will provide discovery of that data through search and visualization services. And we will distribute that data for local and cloud-based analysis and visualization, something we're doing at the moment at a rate of about 200 petabytes per year. Okay, and with that, I'm going to hand over to Tim Goff. Are you ready, Tim?
Let's see. Moment of truth. If I think I need to be added as a co-host again. Saying host disabled screen sharing.
Oh, okay. Yes. All right. Try that again.
That looks like it's going to be promising. All right. Can you see a screen with stuff on it? It looks like a presentation. Do you see my presentation, my title page?
Yes.
You're good. Yeah.
Awesome. Sweet. Okay. So good afternoon. My name is Tim Goff. I'm the platform architect for the Earth Data Cloud on the EED program. And I think a lot of you are familiar with what we do, what the Earth Data Cloud is, and Doug gave some background on that as well, but I'll go into that in a moment. And also with me today is Jimmy Sanchez, who's the Earth Data Cloud product manager. So the intent with this presentation is to give a quick overview of the Earth Data Cloud and then discuss some of the challenges and new approaches as we continue to evolve an efficient and scalable data archive. And if you have any questions, I think there's Q&A later, but also Jimmy will be watching the chat, I believe, and responding if necessary there. So as Doug went into, Earth Data Cloud's gateway to Earth observation data, and we hold over 128 petabytes of Earth science data, and 200 plus petabytes are distributed every year. And the majority of this data and associated services are hosted in the Earth Data Cloud, which is provides a compliant cloud platform in the AWS commercial cloud. The Earth Data Archive has its beginnings in the late 90s, and originally data was stored in on-premise tape silos. I was lucky enough to get this picture before they moved the tape silos out of the old Landover building where the project used to be. And users requested data that was stored on these tapes, and it was asynchronously pulled from the tape and staged for either retrieval over FTP or delivered on physical media such as DVD and CD and magnetic tape. There were some limited transformation services available, but granules generally were delivered in their archival format, which usually was HDF and then later on CDF. And most processing ended up having to be done by the end user on their own computing resources. In recent years, the majority of the archive has moved to the cloud, and specifically Amazon S3. Cloud storage allows us to prepare for the archive growth that's expected without needing to directly worry about hardware procurement, and enables access to data via HTTPS and S3 protocols. And we're able to co-locate data from multiple providers and DACs in the same AWS region, along with the tools and services which allow end users to pull only the specific data they need without the need to download entire granules. And we can keep that, we can keep the actual volume of data that has to go out to the public internet at a minimum, keeping the system a lot more efficient. I think the biggest shift here is the ability for end users to also co-locate their workloads in the same AWS region with the data and effectively avoid that egress at all. the data can just stay within the AWS cloud boundaries, and it's a lot cheaper and a lot more efficient, and everybody's happy. But we've been doing this cloud thing for a number of years, and there's still more challenges to address. The exponential growth of the archive that led us to move to the cloud in the first place continues to be a problem, especially as Doug mentioned with NISAR and other missions, which increase the velocity of data growth. This really does look like a exponential curve here, and with NISAR, it's only going to get more exponential looking. I guess that's the point of exponential. It's going to go up, up, up. And then new access methods and patterns like chunking and other approaches that there's been a lot of talk about the last few days at ESIP drastically changed the assumptions that we used to be able to make about how our data is going to be accessed and how we have to architect our systems. Among other things, the archive is no longer meaningfully seen as a collection of files. It's a cube of data that can be accessed in weird and interesting ways that don't align with file boundaries. And then, of course, as with everything else in the world today, AI and machine learning advancements make things even more interesting with new access patterns, as the archive might be used to train models, and researchers might vibe code their scripts that might use not the best approaches for accessing data and might be, doing things that are way suboptimal. And so these challenges have led us to question our prior assumptions and rethink our approaches, and I'm going to discuss a few of those here. And I forgot to start a timer, so hopefully I'm no idea how I'm doing time, but I think I'm doing okay, hopefully. Okay, so access patterns to the archive are not uniform across all the data, and they're also not predictable over time, making a one-size approach to storage inefficient. S3 provides multiple storage tiers with lower cost for a smaller reduction in availability, but predicting and manually managing that data location would be pretty difficult to do. Luckily, S3 provides the option of intelligent tiering, which will do this for us and move data automatically between tiers based on its last access. You can see here in this chart on the left, the blue is the data that hasn't been accessed for over 90 days, and it's in the cheapest storage, and the red data is most recent access or creation is within 30 days. After some initial stepwise looking graph of as we brought new buckets online and they aged into the lower tier, it's relatively stable. We're keeping within an envelope of a kind of consistent range here. Now, again, usage patterns are dynamic and there's fluctuation. We had this, pulling entire collections caused some stuff to be pulled out of the archive, but it reverted back to kind of essentially a mean of how much of the archive tends to be in the steepest storage. And even with that, and you can still see it in this chart, but we kept our savings over the equivalent volume in standard S3 always stayed within 40 and 60%. So that's a pretty good saving. It's significant savings that we achieved just by making this change and putting our data into intelligent tiering. I will note here, as if it sound like a pharmaceutical commercial, you should ask your local AWS TAM and your cloud architect and others whether intelligent tiering is right for you. There are costs associated with the movement of data between tiers. Any enterprise agreements you have with AWS will affect things. So, whether this works is going to be dependent on every system, but for us, this has been a huge cost savings. It's been awesome. I also note that our current configuration only enables the synchronous tiers of storage. So data is always immediately accessible, immediately being, within seconds, the lower tiers maybe take a slight amount more time, but data does not have to be requested and restaged. But there are lower tiers that are cheaper that require asynchronous access, and we might consider looking into those in the future for very infrequently accessed data. But that would require additional tooling to make that work. For now, we're sticking with just the synchronous access tiers. As Doug said, data storage is our largest cost driver. But when we started building the Earth Data Cloud, we thought that a big driver of cost uncertainty would be data egress. And so we built these complex systems to impose predictable upper limits on the costs associated with data egress. And then because we were mostly a system focused on delivering data, we just assumed kind of all endpoints would be the same, and we applied those same controls to every kind of endpoint, including APIs like CMR and static web content like Earth Data Search. But those endpoints are, even if they go over budget of their tiny fraction of the overall ESDIS and Earth Data budget, that's ultimately not a huge overspend. And actually, we could be throttling and cutting off access to those endpoints, even if our overall budget was well within spec. And furthermore, we found that the egress has not really been as uncertain and has been a lot more predictable than we expected. It's not really driving our cost uncertainty. And since users in recent years have, and especially the last 6 months, have really moved to using direct S3 access instead of HTTPS access, which is effectively free if it's in region. The actual egress costs have gone down significantly, even as the total volume has gone up significantly. So those original assumptions have kind of needed to be reevaluated and changed. You can see here, this is sort of a visualization of our throttling method. On the left, we have multiple applications showing their percentage usage over a month against whatever throttle is configured for that application. And what we have done in the last, and I think since May or so, is moved to a enterprise level throttle, so an enterprise level budget. So through the month, we're instead of viewing these spaghetti model of different budgets, we're viewing one. As long as we stay below this line, we're good. And if 1 month a particular provider has a huge spike, but another provider is below, it all balances out in the wash, and we're not impacting the smaller applications that are not really significant contributors to the overall egress cost. The next challenge and thing that we have addressed or tried to address or in the process of addressing is as a responsible steward of our archive, and our job is holding onto the data and archiving it, making sure it doesn't get lost. We maintain backups of the archive, both in some cases in the cloud and separate accounts, or on premise, which means we're storing multiple copies of the entire archive, which, no matter how you're storing that, does get quite expensive, especially at the volume of data we're talking about. And this approach to disaster recovery, it's kind of standard approach to disaster recovery and resilience, is intended to cover all types of scenarios, whether it be hardware failure or malicious deletion or natural disaster, whatever. But we're storing the data in S3, and S3 gives assurances of resilience. It has data centers that are geographically separated, and they have redundancy built in. So we're really already paying for infrastructure to protect against drive failures and disasters. With this in mind, we can focus instead on hardening the management plane and protect against unintended deletion and how we recover in that event, rather than on the kind of eventualities that are already being addressed by AWS. So this is still a work in progress, and we haven't enabled this yet, but we're working to make use of S3 versioning and object lock to, instead of retaining a full backup of everything, as you see on the left, we're keeping, when a data object is replaced or deleted, the version will be kept for some period of time, and then there'll be a period of review before it is finally deleted. And that way putting aside that there are actually redundancies and duplications already within the data storage in the first place, we are only keeping additional copies of a much smaller percentage of the overall archive. And we're working on how to make that secure and cost efficient, and to integrate that with our system. So that's something that will be coming in the future, in the short term, near term future. So while the Earth Data Cloud is built to handle large volumes of users and data, the shifting access patterns that we see and continue to see constrain shared resources and degrade performance of the system. And this could be the result of a malicious denial of service attack, but in our actual experience, more often than not, it's a well-intentioned script or somebody doing something with a new access pattern that just isn't scaling well, is causing inefficiencies, or we're not working well with some tooling, and rather than something malicious. And in these cases, also the contention often accumulates at shared services such as Earth Data Login or CMR. And when we do see these events, we are able to, because we have EDL registration, and we can reach out, we can see who is accessing the data. We can reach out to them and say, hey, we can help you do this more efficiently. We've worked with tool maintainers such as Earth Access to figure out, a lot of users are using this tool. This is an awesome tool. Like, let's work to make sure that we're, we know how each other's systems work, and we can build in efficiencies. We made some significant improvements with Earth Access a year or so ago, where we helped them to use EDL a lot more efficiently, which meant their users were happy, and also our system was happy because we were drastically reducing the number of authentication requests that were necessary. So yeah, we reach out to users and tool maintainers, and also tools like AWS WAF and Shield provide some protections against DDoS and similar DDoS-like things. But in addition, and what I want to talk about here is user-level rate limiting, which we've added in applications specifically in the last couple of months to EDL. Instead of a single user exhausting the system resources, as you see on the left, and degrading the service and denying service to other users who are well below their threshold of normal usage. Instead, we are imposing a reasonable limit for all users. And so once they hit that limit, they will be throttled, so they're not able to go over the limit. The system as a whole remains well within its normal parameters, and other users are not impacted. And that's proven to be very successful with EDL, and they've been working to tune the threshold to make sure it's not cutting off people who are doing normal things, but is also protecting our core systems. So most of our access methods in Earth Data optimize for the idea of finding specific data you're looking for, and then downloading, ideally just the part of that data that you care about, either single granule file or even a smaller chunk of that granule file, and ideally into workflows running in the same cloud environment, where it's more efficient to access it. But there are always going to be workflows that require pulling large numbers of granules, whether for a reprocessing campaign or a consumer like a Planetary Computer or other huge consumers that need access to the actual underlying files on a very large scale. And in those cases, we get into some significant inefficiencies because they have to search, authenticate, download each granule, and they cycle and loop around on that, and it overloads our systems, and it's inefficient for them. So for such as I have started referring to them, petabyte scale consumers, we've started to pilot a program to allow direct native access to the archive via S3 request or pays. And since Earth Data Cloud is no longer responsible for the egress charges, we can remove some of the constraints that are normally in place. So, for instance, we can remove the requirement to keep S3 direct egress within the same AWS region, and allow download to other cloud systems, other AWS regions, and on-prem environments. And also, since currently this, and I should stress here, this is by invite only. This is a pilot, and this is not a general availability feature. But since we are only interacting with users that we have a pre-existing relationship with, and we've invited to be part of the program, we can relax EDL registration requirements because we can rely instead on AWS authentication. We know what AWS account they're coming from, and we can provide access directly to that account and handle user access agreements and communication with the end user that way. So using this approach, these petabyte scale consumers, as I've shown on the right here, can access data in bulk with much fewer requests than using normal access methods, as shown on left. And also, they can, instead of having to pull data out in order to put it into your own bucket, they can copy directly from one bucket to another, which I know is something that users have been unable to do in the past. While this pilot has been a success, it's currently on hold. We have one consumer of this, and we're holding it that for the time being. But certainly, let us know, if you're interested in, if and when that becomes something we expand further, then we will let you know. And finally, this is my last one, I think. So with the exception of request or pays, as I just mentioned, all end user data access requires user registration through EDL. And this is done to enforce access agreements, especially for international data, and also to enable user engagement, as I mentioned before. This leads to users having yet another credential they have to remember and have to rotate. And also, Earth Data has to hold on to its own user store and keep that patched and secure and managed and everything, and all the overhead that goes along with that. So to address the proliferation of logins and simplify this, Earth Data is rolling out Identity Federation, which will allow users to authenticate with existing external identities, which at the moment initially is limited to Google, although we hope to incorporate additional providers in the future. GitHub is one we want to incorporate. We've also been talking to some other teams that have informed us that it would be very helpful to include the European Space Agency identity provider. So we're looking into that. Ultimately, while Earth Data Login is not going to go away, we want to avoid Earth Data Login having to maintain its own custom user pool. And ideally, all authentications would be federated to other systems. We also have a federation with NASA's identity provider system, which allows those of us who have NASA identities to use those instead of having to use Google or an existing Earth Data login. We also mentioned we use the KeyCloak utility or system, open source an identity management system, which has worked out pretty well for us thus far. In addition to simplifying Earth Data Login, Identity Federation also serves as a single hub to connect client applications with identity providers without each one needing to integrate directly. So if we added a new identity provider backend, each in the current system, each client would have to integrate directly with that provider, but we're adding this system in the middle that helps to tie them all together, especially when these clients often don't have a big active development team. This lets us bring the value add to those clients without them having to do it themselves. And also, especially with, like I said, we have the NASA identity provider integrated, and as well as other things that provide MFA and to provide higher assurance level of your login. And using that, applications can specify a minimum assurance level to say, I only will allow users that have logged in with a non-phishable MFA, or only allow users that have logged in with a NASA PIV card, et cetera. So we can tailor the access requirements to each client and even potentially to resources within each client.
Over time, Tim.
Yep. And conveniently enough, I am done. So that's all I have. I'll take questions in the chat or in the Q&A section.
Yeah, and we have a Q&A session after the next talk. So either put your questions in the chat or keep your powder dry until Shannon and Tyler are done in their allotted time space, Tim.
Yeah, I told you I'd be only 2 minutes over. I think I went more than that, so sorry about that.
Yeah, a little bit more. All right, can you stop sharing so Shannon and Tyler can? Thank you, mate. All right, over to you guys.
All right, I should be sharing, and Shannon is going to kick it off.
Yeah. Hey, everyone. So I'm Shannon Leslie. I'm at the National Snow and Ice Data Center in Boulder, Colorado. We are one of the NASA DACs. And there I'm the data stewardship manager, but pertaining to this talk, I'm the lead or sort of in the agile world, the product owner for the metadata stewardship team, which Tyler and I will be talking about today. And so I think Tyler Stevens, many of you know, right? He's with the NASA ED program based in Baltimore. And he's the Scrum Master for the team. So, we'll be talking today about advancing NASA's Earth Science metadata quality through collaborative stewardship. So Tim just gave, a great talk, I think, really in sort of the technical solution space. And Tyler and I we're going to sort of shift gears and talk a bit more about sort of the human dimension in sort of the solution space and what collaboration has really helped us achieve. So go ahead, next slide, Tyler. So, we'll just touch on sort of some context, why this matters, the team that we've built and how it works, what we've achieved, and then we'll wrap up with sort of what's next and why it scales. Next slide, Tyler. Okay, so why is metadata stewardship needed? I was thinking about this morning. This is like speaking to the ESIP community is a little bit preaching to the choir, but I'm going to preach anyway. So, I think ESDIS comes from a place of strength when it comes to metadata quality, metadata curation, right? We have decades of experience in curating metadata. We've traditionally, kind of historically had, really discipline and mission and science user community focused DACs, right? And I think that has built an archive of metadata that is diverse, and I think we should see that as an asset. It means that the metadata is rich and it's scientifically meaningful. So on the left, that sort of represents this discipline-driven diversity, right? But over time, right, that local optimization, right, for certain user communities, certain missions, that sort of it worked well for a while, and the quality of metadata hasn't changed. I think what's changed today, kind of shown in the middle there, is the new environment we're working in, right? So we're increasingly sort of funneling metadata through the single metadata layer. Think CMR, right? And more downstream applications, websites, services are being built on top of CMR. So that one sort of, that diverse metadata, when it's sort of pushed through the single layer and out in these various applications, it starts to surface as sort of inconsistent metadata, right? So, I think while that, I think in this modern environment, and given just modern needs around, right, the converging systems, future-looking technologies, that discipline-specific like metadata alone just doesn't scale. So that's really why we need this sort of collaborative coordination, so that we can take that really rich metadata and just make it a bit more consistent and interoperable, so that it works better in sort of this modern environment. You can go next slide, Tyler. So, given that need, we were very intentional and continue to be very intentional about how we build this team and how we run the team, and just how the team runs. So we're really focused on practical implementation and measurable outcomes. And what I mean by that is that we're not really focused a lot on theory or policy. We're really just trying to improve the metadata, right, as quickly as possible, right? Given the most practical solution, often leveraging existing solutions. And that sort of gets at my second bullet. So, we're guided by the broader ESDIS-wide needs, and as well as, right, the community, like meaning the DAC community, the ESDIS community practices, right? We're trying to leverage existing solutions to tackle these kind of bigger problems. With this team, while we're trying to learn from the various discipline-specific kind of practices, and share knowledge there, we're trying to move away from siloed approaches. So we've got a charter-driven participation model with defined roles, and this is somewhat new development in sort of our team, and this was largely designed to allow for DAC participation and different DAC capacity, right? It recognizes that not all DACs can participate at the same level at any given point in time, right? So, it allows us to really continue to get that inclusive engagement, right? We really want those people, those experts, to be involved. But it also allows us to have a bit of structure and accountability as well. And last but not least, it is all about the people. I can't speak enough to this. So we've got folks that span sort of the DAC science disciplines and really operational metadata curation. We've got folks who have, like Tyler and others, who have, expertise in these enterprise metadata systems and schemas like CMR. And then, of course, we also have folks who are involved in the broader community, stewardship community and standards bodies, like ESIP and like OGC and others. And go next slide, Tyler. Okay, so I'm I mentioned that we're sort of an outcome-focused team. So I just wanted to briefly touch on a few outcomes, and Tyler will go into more detail on these in a minute. But so starting on the left, I suspect many of you have heard about the Web Unification Project, which is essentially building the new Earth Data website. And our team has been involved since pretty early on. Really, our goal is to ensure that the metadata, over 40 metadata elements that sort of are displayed on the website on now over 10,000 dataset landing pages, representing ESDIS datasets. We have been involved to really ensure that that metadata still continues to be scientifically meaningful, but also just more consistent across, right, all the DACs across ESDIS. And then the next one there is publications, citations metadata. So what this is it's citation metadata for publications like journal articles that cite ESDIS datasets. So we sort of went from a DAC by DAC solution. Some DACs didn't even have any solution in place, didn't really have a way to capture these sorts of citations, to now we've got this cross-DAC enterprise solution that now we are operationally supporting with over 32,000 citations. And my favorite part about this is really that we leverage an existing solution, in this case from ESDIS, that they had in place, but our team just helped scale that up and provide a framework for sort of governance and sort of the continued support of that metadata. So metadata quality validation. So just through really, I'd say, collaborative curation and coordinated curation and sharing of workflows, sharing of workloads, across all as like 15,000 or so data sets. We've increased validation by 30% just in under 6 months. And then last but not least, our team participation. So we started with 3 members in April of 2024. That spawned really by the Earth Data Web Unification Project, and now we've got over 20 members. We've got representation across all of the DACs, and I had mentioned before, others involved as well. And what's the kind of upshot of this is that as we've grown in capacity and grown in expertise, we've been able to take on more, right? I mentioned we sort of started with web unification readiness, and you've seen since then we've tackled citations and metadata quality more generally. So let's maybe go to the next slide, Tyler. Oh, okay. So yeah, Tyler is going to take over and just talk to you how we put this into practice.
All right, good afternoon. So yeah, Shannon mentioned I am the Scrum Master for the Metadata Stewardship team. And just a quick apology, I have my camera on one screen and I have the slides on another screen, so my eyes may be going back and forth. So as Shannon mentioned, right, the Metadata Stewardship team, the way we do things in practice, we work within the SAFE framework. So that's, lean, agile, and operational practices. So within that framework, we're a cross-functional agile team that sits on the EED search and discovery train, and embedded within that, we, as Shannon mentioned, also we have the metadata stewards across all the DACs, and we're embedded directly into that Earth Data ecosystem, including the enterprise system, Earth Data Search, Earth Data, CMR, UMM, the Unified Metadata Model, the schemas that drive the CMR for certain discovery of collection services, tools, variables, citations, and some other ancillary type of metadata. So as part of that process and planning, we do have our program increment planning, where we plan the work, incrementally deliver the value and outcomes that were mentioned on some previous slides, always having communication with our customer, in this case, Doug. So we have that direct feedback with him and ESDIS on all of the work that we do on our team. And get feedback, and replan and iterate on that, throughout the PI, throughout our sprints. So we have our core members who directly lead or actively work on team objectives. They're able to participate the most, have the most capacity on our team. The advisory members, while not able to participate at the same level as core members, they do contribute various expertise and review and review specific things across some of the different projects we're working on. And we have that knowledge, process, and sharing. And then, from that, from both our core members, advisory members, and others, we have that, consensus-driven decision maker. We're not making, siloed decisions across specific DACs. We have that community and group level type of decision making that drives the best possible outcome that we can do for the community. So as Shannon already mentioned, one of the initial drivers to start the stewardship team was for web unification readiness. And the overall mission of web unification is to improve discoverability of Earth science data, and just provide that consistency across platforms. So as most people know, historically, each individual DAC had their own landing pages, had their own systems and discovery tools for this. So this is kind of just to build that consistency across across ESDIS platform, and make more effective ways for users to access data, reduce redundancy, and just improve overall usability. This has been a multi-year approach starting back in 2024. And this image here on the right-hand side just kind of shows the schedule for various DACs onboard into web unification. So we just finished a Group C DACs in the winter, last fall, and then going into this winter. And we have Group D and Group D and E coming up this year. Right. As I mentioned, we were, the metadata stewardship team was embedded early into that process. We work with the web unification team, Andy Thomas and her team, to support that effort. And, kind of from there, we looked at UMMC in terms of how UMMC maps to the dataset landing pages. There were some inconsistencies there, so we also addressed that. We discovered some schema issues that, as a metadata stewardship team, we kind of resolved and iterated on that to make incremental updates to UMMC to support that. And then once those changes were in place, we updated curation guidance as well as the actual curation efforts to propagate those changes to the metadata to improve the content on the Earth data, landing pages. And this kind of was needed to make sure that we were consistent and accurate in terms of the information that was being presented to the users when using the Earth data search discovery system. So this slide right here, this just shows kind of a high-level summary of all the collection metadata fields in UMMC, and we kind of did a mapping from that because sometimes the naming convention that we had in UMMC wasn't directly tied to the naming convention that we had on the Earth data landing pages. There was an initial mapping done by some of the DACs, I believe, and then the Andy and her Earth data web unification team, but came to metadata stewardship to kind of get some advice on that and make some recommendations just to make sure that the proper content fields was properly being mapped to the correct information on the Earth data set landing page. That's a screenshot on the right-hand side. So that was a big effort as part of the web unification. Another one here, as I mentioned, the publication citation metadata to cite journal articles. The first thing we needed was a new citation schema. So we work closely with the metadata stewardship team to build out that new schema and work with CMR developers to implement that within CMR and have that available for population. So there was a GESDIS developed DOI trace workflow. They already had a process that worked for GESDIS, so that was built and scalable out to all the providers to be able to ingest citation metadata into the CMR. We established an operational agreement that formalizes the roles, responsibilities in the process, and the overall cadence for that curation and ingest, and basically how that will continue over time. And so metadata stewards can add and update publication citations. Currently, it's mostly automated process to a script that runs. I'll talk about that more in a moment. But currently, across the we have over 11,000 citations associated across 1,200 as this collections. But in total, we have over 32,000 citations that we have collected through this process. Right. So the way this works, and like I said, this was initially done by GESDIS, but now operationalized across all of the DACs using the DOI trace workflow and the CMR citation management. Basically, publications, they're linked to the ESDIS data DOIs, citation metadata from Crossref, and also additional information abstracts from some of the other entities like Open, Alex, Scopes, and SciX, and then that all gets fed through that automated process into the CMR publication citation schema, and then that metadata is then ingested into CMR. And also, as part of that process, those citations are associated to the collection. So what we don't have yet, but we're working towards, is eventually having the citations being displayed on the Earth Data dataset landing pages. But over here on the screenshot here on the right, this shows what it currently looks like in the CMR landing pages. So for a given collection, you can see there are 79 citations associated with that collection. So we'll eventually propagate that to the Earth Data landing pages on the Earth Data website. So users will be able to discover those collections based on the citation. Some ways we can do that via DOI, short name, GCMD keywords, and maybe other ways to do that where appropriate. But we're still working on that, and that's going to be some upcoming things that we need to work on. Right. So sustaining metadata quality at scale. Right. This was kind of done previously in siloed fashions, but we were able to, in the metadata stewardship team, to do that via coordinated, sustainable method to validate metadata and correct and update that metadata, right? Switching from those specific DAC efforts to the whole sustainable workflow across the enterprise. So, right, we do that via, we have a validation script that we can run to generate reports and metrics to determine the quality of the metadata, and then that's coordinated across the DACs to correct that. And then as part of that effort, right, we're maintaining that curation guidance and also keyword governance related to the quality of the metadata. I'll talk about that more in a moment. Some other things we're looking at actually exploring this PI to build on that semi-automated approach to see how where we can be fully automated in some places, to look at AI and other things that we can use. So we're developing use cases and kind of testing out some things with that for potential future implementation. And as I think Shannon already mentioned earlier, currently we are at 73% valid, up a big jump from the 43% we had last summer. Right, so the semi-automated curation workflow, right? We detect the issues in the metadata by running the validation scripts. We distribute those results to the DACs, and this is generally like a CSV report. They're all accessible. Then from there, those reports are reviewed by the individual DAC representatives who have the science expertise to just to verify that what is in the report and what the recommendations that are being made are accurate, appropriate, and have that scientific context. And then from there, the updates are implemented by the DAC using the semi-automated approach or MMT as well to or other tools as appropriate to correct the metadata. Right, as part of that too, I think a lot of people here know about the GSDMD keywords. Those are the keywords that are in the collection metadata and others. We do have a governance process for users, stewards to actually suggest keywords, and that kind of goes through a process. Generally, new keywords we could add, but if there's changes, modifications being requested in the keywords, we from there need to do impact assessment to determine the appropriateness of that, and also what impact that has to other metadata in CMR, just to make sure we're not making something that's valid to make that invalid instead. So there's a whole governance process for that we follow metadata stewardship, and also the community who requests keywords. I'm going to turn it back to Shannon for looking ahead.
Yeah, thanks, Tyler. You can go to the next slide. Only a couple more slides. So in terms of what's next for us, we'll continue to improve metadata quality through the methods that Tyler already talked about, including, of course, he mentioned we're sort of exploring responsible AI-assisted curation, working with the CMR and other developers on this. I think the other thing wanting to do more strategically is to really take a step back and look at sort of modern and future, the needs of, modern and future downstream systems and users of metadata, to make sure what we think is good metadata quality still makes sense in that context, right? And maybe we need to evolve a bit on that. I think expanding our work to additional metadata types, certainly, and some work we've actually already started on as well is converging on some of our metadata curation tools, workflows, practices, really, to get more efficient and to make everything a bit more sustainable. Next slide, Tyler. So, that sort of those next steps build upon what we have, and just given the context of, I would say, this ESIP meeting and this session, right, on sort of the state of ESDIS, I did want to just, again, look at the bigger picture from what I think of this team, right? I think we've got a great model that is actually sustainable and scalable. First and foremost, it treats metadata stewardship as a foundational service. So, we're not a temporary group. We're not voluntary. Really, we have this effective approach that is grounded in, we've got this transparent, and Tyler had mentioned this consensus-based decision making. We've got a lightweight, but also structured and funded collaboration. Those aspects are all so key to this idea of a foundational service. And in addition to the, tangible outcomes that Tyler and I talked through, there are so many other meaningful improvements that we've seen. So, this higher quality metadata, right? And the important thing here are, again, the people, right? So it's informed by this cross-DAC, cross ESDIS, right? Many other experts, this expertise, right? We're sort of improving quality while still continuing to make it scientifically meaningful. We've got agreed upon practices, and I think we've achieved that through shared ownership on the team, right? This transparent, consensus-based decision making. Something we didn't really get into is sort of, we have kind of a distributed leadership model on the team as well, where team members kind of take ownership of certain initiatives on the team. And I think we've seen that really increases adoption of these practices and leads to really sustained consistency. We've been, I think, building trust and alignment across the organization, at least when it comes to metadata. And another, I think, outcome of this is really more organic, maybe not so much top down, just more organic progress toward change and convergence from, the experts themselves. So, I think we're adaptable and ready to support, future work wherever that is, as priorities and potentially organizational structures evolve. So just one more slide. I just want to really thank you all. And of course, thanks to the wonderful metadata stewardship team and everyone who made it possible. Thanks.
Thanks, Shannon. Thanks, Tyler. We're going to move into the Q&A section next. And then when we're done with that, I was going to give a brief thank you to ASIP and explain why I think ASIP is very important. And I'm going to preempt some of that now, because one of the reasons ESDIS has been so committed at this point in time to metadata quality improvements is because of an ESIP session about 2 years ago, maybe 3 years ago, where we presented a user working group session for Earth Data Search. And I was staring at a list of the top 10 problems with Earth Data Search. And I looked at the first one and I thought, that's not an Earth Data Search problem, that's a metadata problem. And I looked at the second one, it was a metadata problem. And the majority of the problems with Earth Data Search were due to poor metadata. That's when I really started getting serious about prioritizing metadata quality. It's a problem we've had in ESDIS since its inception. And it's not through lack of the ability to fix those problems, lack of the skills, the commitment, but it's just we've had higher priorities and a lack of resources to deal with those problems. It was that ESIP session that made me pivot towards trying to solve these problems and give this group the resources and the time they needed to solve it. So I think that's a very good example of the power of and value of ESIP. And I will speak more of that after the Q&A session. But do any of you have any questions either about the two presentations you've just seen or a question for ESDIS in general? The floor is open, and hopefully everybody's off mute now, Zoe, so they can start heckling me.
Yes. People can raise their hands with the React button at the bottom, and you can call on people, or people can unmute themselves and ask a question.
Excellent. The more questions you ask, the more unlikely it is that I will get on a soapbox in the next few minutes. So, there's a lot at stake here.
Hey, Doug, this is Corey. This is not a planted question, but just wondering if you want to walk through your thoughts about agentic AI in search, or if you want somebody else to do that, they can do that too. But just wondering how you see that being implemented and kind of where you see that going.
I can give a high level, and then anybody on our side of the ESIP ESDIS divide with a technical answer this can go. But the way I see our ESDIS's approach to AI at ML is kind of twofold. One, the scale of the systems that we are building and the data that we are preserving and the budget that we have make it impossible to sustain using our current approach of manual intervention, manual monitoring. So automation is going to be key, and automation to be effective requires building off these AI and ML technologies to gain efficiencies in cost, improvements in reliability, availability, all of those fair things. On the other side, with the advent of things like ChatGPT, we are seeing a shift in how our users may want to interact with our tools and services. I can see in a not too distant future where it will be the expectation of our users to be able to interact with something like Earth Data Search using a prompt-based user interface. And that is something that we are working to now. We have that API, we have that user interface, and we're in the process of integrating it with Earth Data Search. And in addition to that, there is a big push by the administration, by NASA, to increase our capacity in the area of AR and ML for all kinds of tactical and strategic reasons. So we have a mandate from them to invest in these technologies, and that is what we are doing. Would anybody from ESDIS who actually does something technical like to weigh in on those things? I used to do technical things. Now I just talk a lot. Okay, so Max asked a question. Hey, Max, how do you decide which collections get moved to a faster access tier in AWS 3? And I think Tim gave the answer, but it's basically the down, and I think it's at an object level, Tim. When was the last time this object was distributed? True story, Tim?
It's correct. It's configured at a bucket level, and for every object in that bucket over a certain size, I forget what the size limit is, but reasonably sized, granule size objects, and it'll move it to a colder tier if it's not accessed after 30 days, and then a colder tier after 60, and a colder tier after 90, and then as soon as it's accessed, it moves back up to the warmest tier. If we let it go, sorry.
Oh, sorry. Go ahead. That makes a lot of sense.
Yep, go ahead. Yep.
Thanks for that. My follow-up question is for those of us who build, services and may test the usability of those services with data sets in these buckets. Is there a metadata flag that we can use to test that we're not moving things between tiers and costing money, and filter out those data sets that are in cold storage?
No, we don't want to restrict what kind of data that you feel that you can get access to based on how much it's going to cost us. And I wouldn't like that to be a driver for you in deciding which data to get, Max. I think the primary driver is what makes sense from a science perspective, right? Or from analytics perspective or visualization. So I wouldn't like to kind of
great. And
you
have my EDL email, so you can always tell me if we're going astray.
Max, I have you on speed dial. Don't worry about that.
And where that becomes more complicated is if we were to ever move to the asynchronous access tiers, then we have talked about the need to have a flag there, because there would be usability issues that we need to work around, and so that's why we haven't done it yet, largely because that does get a lot more complicated. Right now, what we've done, it should be transparent to end users, and that's the intention.
Really cool progress. Thank you. Go ahead, Doug.
So there was an earlier question about request appears for NISAR. The answer to that in the short term, Joe, is no. But we'll see how this pilot. Oh, he's come on camera. He's ready to fire back. Hi, mate.
No, I'm ready to beg. I will beg.
I love the fact that you're ready to pay, and this points out that even though this kind of access pattern is going to cost the consumer of it money, it may work out cheaper because of other hoops you have to jump around for purely being able to access it in the US West 2 region.
It doesn't cost me money if I'm in US West 2, though.
No,
it's
it
only
doesn't.
if I'm
But the
egressing
very
out.
fact that you're asking for request to peers means that
Yep.
you want to get it out of US West 2, and the way you're doing it at the moment is probably costing you more than it would if we were allowed request to peers, right?
So I actually want requesters pay for observability and tool use, not for egress. So requester pays gives me a public bucket I can see, and then I can use S3 tooling or S3 aware tooling a lot easier than doing the 1 hour pull the lever token to get access. So I'll be in
So
US
maybe
West
there's other
2.
ways to solve that
Yeah.
without you spending a lot of money as well.
Yeah,
Something to look
I
at.
wouldn't pay either way, right? But that gives you the egress protection and me the observability and tool use.
We're sending you a bill, you, Joe.
That's fair.
Any other questions on request to peers or anything else for that matter? Oh, there's a fight going on between Luis and Joe, so you guys sort that out for yourselves.
We're supposed to be in another meeting anyways. We'll fight there too.
All right. Any other questions? You can ask any question about ESDIS or NASA's Earth data capabilities, science data. Have at it. Luis has got his hand up. He may be continuing the fight with Joe. We don't know yet.
No. It's not about that. It's about new products. I guess new processing levels for products. So you guys know HLS as a, I guess, successful kind of data set because it has pre-processing, and you pre-process, Landsat Sentinel. You get to this nice collection that everybody loves to use for machine learning. And I was wondering if that approach would be kind of like a template for other products that might become more like HLS, well, not HLS, but the kind of some pre-processing, so or integration, harmonization, so they can be more useful to the community. So I'm thinking of a level 2.5 data set. It's not like as it comes from the data producers. It's more like, okay, we have some ownership in making it more usable. Not necessarily all the ways are, but something that will be easily integrated into those more cloud native pipelines.
So there are a lot of what I would refer to as XR data set ideas. X being, the R being ready. We've had analysis ready, cloud ready, AI, ML ready. And in our roadmap, there's a big chunk of time looking at AI, ML ready data. That's going to tackle part of your problem. I think one of the big selling points of, and correct me if I'm wrong, I'm not an expert in this, this is a naive opinion here, of HLS is that it offers a broad amount of data that's been spatially and temporally by combining different instruments and doing the legwork of what was it? How did Podak had the data matcher, getting the projections aligned, getting the resolutions aligned, all that sort of thing. I'm struggling for the terminology there, but I think HLS solves that problem for you, Lewis, in 2 dimensions, right? Getting that highly cohesive data set over a large period of time, over a large area of the Earth, and making it usable by AI and ML pipelines. So we are looking to tackle one of those 2 things in the not too distant future.
Thanks. That's cool.
It's a little intangible at the moment, but it's definitely something we're working towards. As we are working towards cloud ready, cloud optimized formats as well. We need to get to some consensus there. There's lots of different options. Obviously, ESDIS isn't in a position financially to duplicate large amounts of our archive in order to support these other formats. But this is where virtualization seems to be a viable option for us, possibly the only option for us as well, given our budget. All right, so I think we've exhausted the questions, but as I said, I wanted to give a bit of a shout out to ESIP. This past year has been very turbulent, a lot of uncertainty. And early in the year, we got all of ESDIS's contractors together in a PI planning session. And I gave a similar monologue, for want of a better word, to them, which I think is equally appropriate to you. And the crux of that is, even though we are in these turbulent times and there's a lot of uncertainty, we have to reflect upon the fact that what we've done and what we do and what we are going to do is not nothing, okay? It is something significant. For example, most, if not all, of Earth science data is in some way in existence because of the work that people like the members of ESIP have done. ESIP members have been and continue to be responsible for all the stewardship, dissemination, and leverage of all Earth science data in the US, a substantial amount of that globally. Okay? ESIP have been doing that for over the past 27 years. The first ESIP meeting was in Washington, D.C. between May the 5th and 7th in 1998. Okay? And we've been doing that, we being ESIP and various agencies associated with them, at huge scales, at petabyte scales. I've talked at length in this talk, in this session, and other people have about the amount of data that we have just in NASA's archive, 140 petabytes, and the fact that NISAR will double that figure. If I want to compare that locally to other NASA science divisions, the heliophysics division has 2 petabytes, planetary has 1 petabyte, astrophysics has a petabyte, and bioscience has substantially less than 1 petabyte. You round that up and you get 5. We have 140. That's a huge achievement by any measure, unless it's AWS, and then it's a morning of, CloudWatch logs. The work that we do and the data that we produce and the science that is derived from that is insanely important, existentially so. Okay? So I'm going to put up a graph. And this is a really important graph. Hopefully you can see that. It's the Keeling curve. This data set was started in 1958 in Hawaii, and it measures the amount of CO2 concentration in the atmosphere. I think this data set is still going on now. And as you can see, there's the upward trend in that. And we've been able to correlate that with the rise in temperature. And this is probably the most fundamental discovery that the world of Earth science has brought to bear. There are many others. This is just the most impactful, in my opinion. Round about my first ESIP, I got some ESIP swag. And one of those pieces of swag was a postcard. And I showed this to some people early on, but I'm going to pull it. It's actually on my wall. This is the Keeling curve in white on black instead of black on white. But this came from ESIP. This is my North Star in terms of why I do what I do. This is the source of it. And it was ESIP that first brought my attention to back in the day. What this demonstrates, and what many other things do, this work has helped prove beyond reasonable doubt global warming is real, that it is man-made, and the clock is ticking. That is incredibly important information. And you guys, over the period of your careers, and the people who came before you and the people who are here now, people who are after you, have contributed to that in no uncertain terms. It is not nothing. You help manifest those things. Earth science data is a public good. And what I mean by public good is it's available to all, and one person does not diminish its availability to the others. This data is free to anybody. We are the stewards of that public good, and our concerns are global, not just the US, not just the Western Hemisphere, not just the Northern Hemisphere, the whole globe, everybody. What we're doing is not nothing. And we choose to continue doing it. We're allowing questions to be asked and questions to be answered. And the scientific method is our bedrock. And we provide the foundation for that method, the data. But there's a human element to that too, a human method. Something that I think within ESIP, we have a huge surplus of. And that method is empathy. I cannot stress enough how important empathy is. And the foundation of such a method is love. And I love you all. Thank you very much.